Okay, so today we're going to work on solving exponential and logarithmic equations. And what we're going to do is we're going to start off with solving exponential equations, and then we're going to move to solving logarithmic equations. I'm going to try to go at a pace that's appropriate for you, even though you're not actually here, and I'm encouraging the sub and you to tell the sub when to stop and pause the videos if you have questions. Try to help each other, okay? And I will be back Monday, and we will be working through this together and answering questions on it again. However, I want to get the basics to you today, and I'll give you a challenging example of solving an exponential equation at the end of that part, and then I'll give you a challenging example of solving logarithmic equations at the end of that part. So here we go. To solve exponential equations, we need to take the log of both sides at some point in the problem. The question is when. And the question is what type of logarithm. Okay? Exponential functions and logarithms are inverses of each other. So if you take the logarithm of the same base as your exponential function, it'll cancel it out. However, there's properties that we have that can help us deal with it if we have two different types of bases in a problem, or maybe if we want to be able to solve this with a calculator, we can kind of get the change of base theorem along the way. We don't have to change the base at the end of the problem. I'll show you how to do that. Okay, let's do a problem, but to solve an exponential equation, again, you're gonna take the log of both sides. You may have to isolate the exponential part first, and we'll get to examples that are like that. Let's do a more basic one first. All right, here's a problem. 2 to the 3x plus 1 equals 32. We're going to do this two ways so that you have two ways under your belt, because sometimes one way will be more beneficial than others, but they both involve taking the logarithm. It's just a matter of which base. Here you go. The first way is to notice that this is 2 to a power, so you can take the log base 2 of both sides. Let's do that. So if I take the log base 2 of 2 to the 3x plus 1, I have to take the log base 2 of the other side as well. This is still an equation. You still have to stay equal. So this is equal to the log base 2 of 32. Now, remember, there are two ways to go about it from here. In general, log base 2 of 2 is going to cancel out. You've dealt with that on the quiz that we just had, etc. However, you can view that a couple of ways. This 3x plus 1 can come out in front and multiply, and then 2 to what power equals 2, and that is 1. Okay? You can also view it as this asks the question, 2 to what power equals 2 to the 3x plus 1. Either way, this whole left side is going to equal 3x plus 1. All right, it's not in the exponent anymore because you took the logarithm of the exponential function, so it canceled it out. All right, that's equal to this over here, which is log base 2 of 32. 2 to what power equals 32? Well, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, so 2 to the 5th power is 32. So log base 2 of 32 is 5. Again, the logarithm is equal to the exponent. Okay, subtract 1, now we just have to solve for x. So subtract 1 from both sides, 3x equals 4, divide both sides by 3, and we have x equals 4/3, and you can leave it like that. That is not the only way to do the problem. It's probably the easiest way to do this problem. However, there are times when taking a natural log or a log base 10 would serve you better. And I'm going to use this example again to show that to you so that we can use it on the fourth example at least. All right, so let's try that. Here's another way to do the exact same problem. So we're not switching problems right now. We're just going to do this another way. Here you go. All right. Still the same problem. 2 to the 3x plus 1 equals 32. I'm going to take the natural log of both sides this time, and then I'm going to use my properties of logarithms. So natural log of 2 to the 3x plus 1 equals natural log of 32. I've taken the same logarithm of both sides, so I'm still equal. It's just that now this natural log of 2 doesn't cancel out like it did so nicely over here. Again, there are advantages to this, and you'll see that in the upcoming examples. Right now, use your properties of logarithms to bring that exponent out in front. Remember, you have a property that says if you have log of a to the x, that's equal to x times the log of a. You can bring the exponent out in front. That's what we're using here. Okay, so 3x plus 1, the quantity times natural log of 2 equals the natural log of 32. Doesn't matter whether you put the natural log of 2 in front of the parentheses or after, but you do need the parentheses. To solve this for x, you could distribute the natural log of 2, but it's not a very nice number, so I would divide it to the other side. So divide both sides by natural log of 2. That cancels out, and I'm left with 3x plus 1 equals, over here I have something I can evaluate in my calculator, or you can leave it as it is actually. But if you evaluate it in your calculator, you're going to get 5. Okay? I think I had that a minute ago. So subtract 1 from both sides again to solve for x. You get 3x equals 4. Divide both sides by 3, and x still equals 4/3. Notice right here, natural log of 32 over natural log of 2, that's exactly like log base 2 of 32 with the base changed, using the change of base theorem. Okay, so there are two methods to solving exponential equations. Both of them involve taking a logarithm. Now let's do another problem. If you have questions at this point, pause the video and discuss that for a few seconds, okay? If not, let's go on to the next example and try another one. Now on this problem, the problem is 3 times e to the x plus 2 equals 75. This time there's a 3 out in front. Anytime you have something outside of the exponential part of the problem, you want to get rid of it, if possible. Okay, so here we're going to start this problem by dividing both sides by 3. I'm going to cancel out the 3 and get e to the x plus 2 equals 25. Now I need to get rid of the e around the x. I need to undo e. Natural log is the inverse of e, so I'm going to take the natural log of both sides. If I take the natural log of both sides, again, and you have to put the natural log in front, all right? But if you take the natural log of both sides, you're still equal. You haven't changed that. So this over here on the left, when I have the natural log of e to the x plus 2, leaves me with x plus 2. On the right, I have natural log of 25, and that's not a nice number at all, okay? If you plug that into your calculator, it comes out to 3.219, but we all know how much I hate rounding, so I would recommend you leave it as natural log of 25. That's fine, but that's equal to x plus 2. Subtract 2 from both sides, and you get x equals 1.219. Or you could write it as natural log of 25 minus 2. That would be, either answer is fine. All right, by the way, natural log of 25, then minus 2 is not the same thing as natural log of 23, of course. Okay, and you can't put this subtraction inside or anything else that you might creatively come up with there. You have to leave it as one of these two answers. The next problem, now let's do one that's very similar to the one we just did. Let's just do another one to get this under our belt. All right, so if you have questions, hold just a second, and if not, here we go. 6 times 10 to the x equals 216. I'm going to divide by 6 first. That will give me 10 to the x equals 216 divided by 6 is 36. I have 10 to the x. I probably shouldn't take the natural log, since if I take the log base 10, it'll undo 10 to the x, and my calculator knows log base 10. Okay, so I should take the log, remember, log without anything written right here, without a subscript, is log base 10, just like ln is log base e. Okay, so take the log of both sides, not natural log, but log base 10 of both sides, and that will cancel out your 10 to the something. Leaves you with your exponent. So x is equal to the log of 36. Again, this is log base 10. You can evaluate that in your calculator. It should come out to approximately 1.556. All right. 2 examples right here that are fairly similar, different numbers, and one base e and one base 10. Again, if you have a base other than e or 10, you have choices. You can take the log base, the same thing as the exponent, or you can take the log base 10 or base e and have the change of base theorem built into the problem like this. All right, let's try one over here. This one's the more complicated one of the solving exponential equations examples. All right, so last solving exponential equation example coming up. Here we have 7 minus 2e to the x equals 5. I really need to get rid of the stuff that's not an exponential function, so I need to get rid of the 7 and the 2. I have to get rid of addition by subtraction, multiplication by division. So you're going to get rid of the 7 by subtracting 7 from both sides. Okay, so negative 2e to the x equals negative 2. Remember up here the 7 was positive, that's why I had to subtract it. The minus after the 7 doesn't tell me the operation of the 7, it tells me the sign of the negative 2. All right. Now I'm going to divide both sides by negative 2 to get rid of the negative 2. That gives me e to the x equals 1. Now, e to what power equals 1? Okay, that's the question you need to ask. I can proceed here by taking the natural log of both sides if I can't answer the question I just asked you. All right, and that'll cancel out the natural log of e is just your exponent, which is x here. So x equals the natural log of 1. Natural log of 1 can be evaluated in a calculator if you do not know e to what power equals 1. Okay, and you should get 0. All right. Because e to the 0 power is equal to 1. Many of you probably knew that. All right, at this point, I'm going to go over to solving logarithmic equations. It would be a good time for you to pause the video. I'm not going to do that on the actual video, so if you want to pause the actual video that you're viewing, that'd be a good thing to do so that you can discuss and answer questions that you have on these examples on how to solve exponential equations. Otherwise, come for a ride with me for a second. Let's move you to the other board. All right. And now let's solve some logarithmic equations. To solve logarithmic equations, we need to do kind of the opposite, the inverse of what we did to solve exponential equations. We took the logarithm to solve exponential equations. Now we need to undo the logarithm. All right, so I need to get rid of a logarithm. I really need the logarithm to be in the exponent of something. Let me review with you really quick. Okay, this is not already on the board. If I have 2 to some power, so let's call it x, if I have 2 to the x equals 2 to the 5th, what does x have to be? If 2 to the x equals 2 to the 5th, doesn't x have to be 5? All right, so if you have two things with the same, two exponential functions that have the same base that are equal, and then the exponents have to be equal. So x would have to equal 5. You're going to use this fact. It's just that you don't have an exponential function in the problem. You have to make it an exponential function. All right, so what we're going to do on all of these is we're going to make both sides the exponent of something that's the same base. Okay, here we go. To solve a logarithm equation, you are going to exponentiate. That's what it's called. You're going to exponentiate both sides. You're going to take the logarithm, you're going to make both sides the exponent of the same base. And I've written that up here. Okay, so let's do that. The first example is log base 4 of 3x equals 3. Since it's the log base 4, I'm going to make both sides the exponent of 4. So I'm superscripting both of the things that were originally in my equation. Okay, and that's going to give me the log base 4 of 4, or the log 4 to the log base 4 rather, cancels out, and it'll leave me with 3x equals 4 to the third. I'm going to write that down because this is the first example. If you know that 4 to the third is 64 and you understand what's going on here, you can write that down in this step. That's totally fine. Okay, so 4 to the third is 64, so I have 3x equals 64. All right, divide both sides by 3. And you get x equals, you can leave it as 64 thirds, or if you want to put it into the calculator, 21.3 repeating, and that's fine too. All right. Now, what did we do? Let's reflect for a second. We had the log base 4, so I made both sides the exponent of 4. That was driven by the fact that my logarithm had a base 4. You really want to use the same base as the base of your logarithm here. Okay. Now, on the next example, again, feel free to pause the video if you have questions and try to discuss those. And if you cannot come up with the answer, maybe have a spokesperson in the class write them down, so that when you come in, when I come back Monday and when we're all here together on Monday, we can get those questions answered. You could also message them to me on My Big Campus or post them on My Big Campus on the discussion board. That would work too. All right. The next example is natural log of the quantity x minus 1 equals 3.8. I tried to make that decimal point really prevalent so that you can see it on the video. Okay. Natural log is log base e. So we're going to take both sides and make them the exponent of e. All right. Natural log and e undo each other. They're inverse functions. They cancel out. So this leaves you with x minus 1 equals e to the 3.8. That's going to be needing to be done in a calculator. Or you could just add 1 to both sides and leave your answer exact. I'm fine with that. I'm fine if you just put x equals e to the 3.8 plus 1. Make sure your plus 1 is down on the same level as e. It's not up in the exponent. If you want to approximate the e to the 3.8, that's fine. E to the 3.8 comes out to be 44.701. All right. So you could put 44.701 45.701 plus 1, which is 45.701. Again, I'm okay with that answer. I'm also okay with this answer. Either one is fine. This one's approximated. That one's exact, but sometimes it bugs people to leave E in the problem. Okay? Now, we start to shift gears a little bit here, because now we have natural log of x minus natural log of 5 equals 0. This is the first problem that you have of 3 that has a natural log, two logarithms in the problem separately. Okay, so here we have two ways we can do this. The first way we could do this is we can just separate the two logarithms in this case. That will not always work. There will be times when you'll have to use the properties, which is what we're going to do second. However, let's do the easy way first for this problem. So you can add the natural log of 5 to both sides. So that gives you natural log of x equals natural log of 5. And then make both sides the exponent of e, because natural log is log base e. All right, natural log, e to the natural log cancels out. So you're left with x equals 5. That's your final answer. Yep, it's that easy. All right. However, there are other problems that you'll need these other techniques, so I'm going to use this example right now to show you another way to do this. Many of you are going to go, why would I do it that way? Why wouldn't I just do it the first way? And the answer is because you might need the properties, so we're going to take this time to review it. What I recommend is that you obviously know your properties, okay? The three properties that are the main ones are the ones that I'm talking about. So if I have subtraction of two logarithms, and I've written this down on the board over there, if I have subtraction of two logarithms, what's that the same thing as? Division inside of a single logarithm. All right, so you can put natural log of x divided by 5, and that's the same thing, okay? Now you have a single logarithmic expression equals something else, and you can exponentiate both sides. So you make both sides the exponent of e, you exponentiate, and you get x divided by 5 equals, careful, over here it's not 0 anymore, it's e to the 0, and e to the 0 is 1, it's not 0. So you get x over 5 equals 1. Now to solve for x, multiply both sides by 5, so x equals 5. All right? This is what we're going to use, this technique is what we're going to use on the next example, which is much more difficult. So just get ready. If you need to pause and review the properties of logarithms, all three of them, then go for it. Okay? Feel free to do that. Pause the video if you need to. Okay, now, here we have log base 4 of x minus log base 4 of x minus 1, the quantity, equals a half. I've written the property up here. Anytime you have two logarithms of the same base being subtracted, that's the same as division inside of that logarithm. They have to have the same base. These do. All right, they're both base 4. So what I'm going to do first is combine my logarithm. That subtraction right there is going to turn into division inside of my logarithm. So I'm going to go division used to come from subtraction of the logarithms. So x over the quantity x minus 1. That equals 1/2, supposedly. All right. We need to exponentiate both sides at this point. So we're going to make both sides the exponent of 4. 4 to the log base 4 cancels out and leaves you with what's inside of the log base 4, because there's nothing else in the exponent other than this. All right, that gives me x over x minus 1 equals, careful, over here, you don't have 4 times that, you have 4 to the 1/2 power. Now 4 to the 1/2 power means to do what? What's a 1/2 power tell you to do? Somebody said square root, I hope. 1/2 power tells you to square root. So you're going to square root 4. Okay? So that's going to give you 2. So you really have x over x minus 1 equals 2. To solve this for x, it's a little more obvious to people if I put it as 2 over 1. You can cross multiply. Multiply both sides by x minus 1, in other words. So x equals 2 times the quantity x minus 1. Back up here. Okay, distribute the 2, and that gives me x equals 2x minus 2. Okay, get x on the same side and the numbers on the other side. So if I subtract 2x from both sides, I get negative x equals negative 2. Divide both sides by negative 1, and x equals positive 2. Okay? Now, I'm putting a warning in this video. I'm about to show you an example that's much more difficult than even this one. So if you are at all confused, please ask the sub to pause it. If you don't get to this last example, we can do it Monday, but I wanted to give it to you in case you had time and to give it to the people that were really understanding this. Remember, you can review this video on my big campus over the weekend if you want to. I am going to give you an assignment as well, okay, having to do with both solving logarithmic and exponential functions. So this last example, all right, we're going to do is more difficult than that last one. Here we go. Clear the board really quick. I'm going to leave that other example up there because you may still be processing it a little bit. And again, don't be afraid to ask the sub to pause the video. Here's the last example for solving logarithmic equations. Natural log of the quantity x plus 5 equals natural log of the quantity x minus 1 minus natural log of the quantity x plus 1. We have 3 logarithms in this problem. That inherently doesn't make it more difficult, okay? The fact that you have a logarithm on both sides could be viewed as more difficult. However, you're going to see where the difficulty comes in toward the end. Okay, so we're still going to use that same property of logarithms right now. I'll put the properties up here in a second so that you have them in case you've forgotten them in 2 days. All right, or still haven't memorized them. Natural log of x plus 5 equals, again, subtraction of 2 logarithms turns into division of something inside of a logarithm. So natural log of, there's my division, the first thing, x minus 1 over the second thing, x plus 1. Now I have a nice natural log on both sides of the equation. I can exponentiate both sides. Let's do that. So make both sides the exponent of e. Why did I choose e? Because natural log is base e, and I want to exponentiate the same base. So cancel, and you get x plus 5 equals x plus 1. How about x minus 1? Sorry, x minus 1 over x plus 1. I need to solve for x. This is where things get more difficult. Put x plus 5 over 1. You're going to need to cross multiply. When you cross multiply x plus 1 times x plus 5, you're going to need to FOIL. All right, that's one way this problem is more difficult. You're going to see another way here in a minute. So if I take x plus 5 times x plus 1, that has to equal x minus 1. FOIL, and x squared plus 6x plus 5 has to equal x minus 1. Folks, that's a quadratic. You have to get this thing equal to 0 and either factor or use the quadratic formula. If you need a refresher on the quadratic formula, relax. I'm going to show it to you in a minute. Okay? But first we have to get equal to 0. So I'm going to subtract x from both sides and add the 1 to the other side as well. So subtract x and add the 1. I'm going to write my result up here. That gives me x squared plus 5x plus 6 equals 0. Now, ask yourself if this factors. If you're good at factoring or if you choose to factor, some problems will be faster and easier by factoring. Okay, so are there any factors of 6 that add to be 5? This is the easiest way to do this problem because 3 and 2 multiply to be 6 but add to be 5. So this thing actually can factor to be x plus 3 times x plus 2. Okay, you can use the quadratic formula. I'll put it on the board for you here in a minute. However, your solutions here, set x plus 3 equal to 0, x plus 2 equal to 0, and you get x equals negative 3 or x equals negative 2. Now, guys, there are things that you cannot take the logarithm of. I can't take the log of a negative number because a positive number to a power does not equal a negative number. That doesn't eliminate all negative numbers from my solutions, but it means I have to check my answers in the original problem. So if I check negative 3 in the original problem, do I ever get log of a negative number? So if I plug negative 3 in up there, I get natural log of negative 3 plus 5. That comes out to be natural log of 2. That might be okay. That's supposed to equal natural log of negative 3 minus 1 minus the natural log of negative 3 plus 1. That's a problem because natural log of negative 3 minus 1 comes out to be natural log of negative 4. I don't think so. E to a power does not equal negative 4. So this whole thing is invalid. That solution is invalid because you can't do that. You can't have natural log of negative 4. Okay? Now, what if I plug in negative 2 instead? Okay, so that would give me natural log of negative 2 plus 5. Well, that's natural log of 3. So far, so good. Equals natural log of negative 2 minus 1 minus natural log of negative 2 plus 1. Yeah, that gives me negative 2 minus 1, which is negative 3 inside of a natural logarithm again. That's natural log of negative 3. I can't do that. E to a power doesn't equal negative 3. The fact that the rest of it is negative is somewhat redundant. Okay? Should have written that up there for you. You can't have this. You can't have natural log of negative 3. These solutions, neither of them work in the original problem, so the answer to this is actually no solution. Okay? And nothing's going to tell you that unless you plug it in. All right? So, if you want to try a problem that's similar to this last example, change this minus to a plus right here and ask yourself, do I come up with any extraneous solutions? That's what these are called. Ones that don't work are called extraneous solutions. You didn't do anything wrong in the problem. You solved it correctly, but they don't work in the original. That happens sometimes when you have a quadratic. Okay, so watch out for that. Your homework assignment, the sub is going to give it to you. It's not too many problems, but again, feel free to do more problems than what is assigned. You need to be comfortable with solving logarithmic and exponential equations. Okay, many of you retook your quiz. If that's still something you want to do, you're going to have to talk to me Monday about it. I really wanted it to happen on Thursday, and I arranged for that to happen with many of you, okay? I hope you have a good weekend, and if you have questions, message me on my big campus, or you can get to the discussion board on my big campus, or at least write your questions down and bring them Monday so that we can talk about them.